Okay, hello, my name is Aida Alvera-Azcárate and I will talk about this poster titled Study of Coastal Marine Heat Waves with High Spatial Resolution Sea Surface Temperature Data, which is some research performed in the frame of the North Heat project financed by PELSPO. Okay, so marine heat waves, I think they are already known by everyone. So these are periods of anomalously warm water. They can be caused by oceanic or atmospheric processes, and they can be observed anywhere in the world ocean. They are becoming more intense, longer and more frequent because of climate change, and they can have a large impact on ecosystems. Now, most of the focus has been done so far into large-scale offshore marine heat waves, and most of the products used so far have coarse spatial resolution, and these are not appropriate for coastal analysis. So, for example, we have here some images of a marine heat wave that happened in 2022. In the summer 2022, in the southern North Sea, we had at the Little Green Cross about 103 days of uninterrupted marine heat wave with a maximum anomaly of 3.6 degrees Celsius. But this product is 25 kilometers spatial resolution. So if we want to focus on a specific region, like the Belgian coast, we need to adequate the products, the sea surface temperature products that we use to determine marine heat waves. We have done a first assessment using the Ostia SST dataset from Siemens from 1982 to 2021 about the marine heat waves in the southern North Sea, the region that you can see in this little image here, and we have observed that the frequency has increased in this region, the frequency of marine heat waves, and the marine cold spells are becoming more rare. The duration is also increasing for marine heat waves, and all this is explained in detail in this paper here, Mohammed et al. 2023, which is detailed in the poster. When we look at the different decades, we can see that the latest decade, which is in red in here, has seen the more frequent, the highest frequency of events of all the data set that we have studied. Now, this project, North Heat, aims at studying the marine heat waves in the southern North Sea, which I had just presented. But then for a specific event, we will try to develop a high spatial resolution sea surface temperature. For that, we will use TNOF. And the aim is to incorporate low and high spatial resolution data together so that we can study the influence of specific marine heat waves into the ecosystems. You can see here an example of a low resolution CCI-SST product and what can be seen in the same day with a high spatial resolution as Landsat 8 data. The region here in the Belgian coast is full of sandbanks in the sediments. So these form specific habitats, and the distribution of heat in these different regions will have different impacts to the organism living in this region. So this is why it is important that we look more detail at the spatial variability of heat distribution during marine heat waves. Now, the approach that we will use for the derivation of high spatial resolution SST is based in DNOF, and we have tried it already with ocean color data. Here it's with turbidity, using Sentinel-2 and Sentinel-3 turbidity data. So the aim is to obtain a Sentinel-2 spatial resolution dataset, which we used at 60 meter resolution, and merging with a 300 meter resolution from Sentinel-3. So the procedure is to merge, to put all the data together. So whenever for a day we have Sentinel-2, the high spatial resolution, we use that, and for days in which there is no high spatial resolution, we use the low spatial resolution, and that is analyzed by DNOF, and DNOF extracts the high spatial resolution and infers it into the final data set. You can see here two examples. One with a day with high spatial resolution turbidity, and this north-south product translate here You can see it here below, so you can see that the initial data in blue and the reconstruction in black are showing more or less the same level of variability. On a day in which initially we didn't have high spatial resolution data, we can see that DNOF is able to get rid of this low resolution and infer the kind of variability that was seen on days with high spatial resolution. So this is the approach we will be using very soon. We will soon have the first results with the SST data. Which SST data we are going to use? Well, for the let's say for the basis, the low resolution or normal resolution data set, we will use available data like VIRS or METOP SST, and then we will infer high spatial resolution from Landsat SST data sets. We can also include EcoStress SST data. And the mixing of all these data sets will allow us to have distribution of the warm anomalies during marine heat waves at a very high spatial resolution. The results, as I said, which will come soon. And if you have any question, just feel free to write me an email, and you can see here the webpage for the project will get fed with the latest results. Thank you.